Hello all, I welcome you all for the session. It's about DT-based class delivery. We are going to discuss about the precision rectifier, right? LIC subject. So in conventional rectifier, they use only diode. So that the main limitation is about forward voltage drop. It's approximately 0.7. To overcome that problem, we will go for a precision rectifier by using operational amplifier so that the main problem of forward voltage drop will be removed and as well as the gain and stability and the efficacy of the output will be maintained. Okay. So this is the overview of precision rectifier. We already know that there are 5 stages, that is empathy, define, ideate, prototype and testing. So let us discuss with our students. So the first stage is about empathy. I invite Mr. Jenshin from second.
To discuss about the empathy part, the main problems are less frequency and low stability and low accuracy.
So next stage is about define. So Divishri from secondary C.
Now we understand the need. Let me define the problem statement. And the electricity supply to our home is 230 volt at 50 hertz. But most of the electronic devices like mobile phones, laptops, and microcontroller based systems requires the low voltage DC to operate safely. So the problem we should solve in this solve is how can we convert the high voltage AC into low voltage DC? DC is smooth and stable to operate safely. While defining the problem, we must explain all the important factors like consider the important factors like voltage reduction, conversion efficiency, ripple factor, power loss, and cost to operate safely. The output should not only be in DC but also in the regulator and reliable. So the components, so the sensitive components like ICs and transistor are protected from damage. So here it becomes the power efficient design challenge.
So next stage is about ideate. So I welcome Danya from secondary C.
My part is IDA. Rectifier is an electronic device that converts the AC signal into a DC signal. Most of the electronic equipments need the DC signal, but our home we only get the AC signal. So the rectifiers are used in the power supply unit. Rectifiers are mainly use the diodes. The diodes only allows the flow the current to the only one direction. So there are mainly two types in the rectifiers. One is off-wave rectifier, another is full-wave rectifier. Off-wave rectifier uses only one diode that converts the AC, only one of the AC signal into a DC signal. It is simple, but it gives only the low efficiency output. It uses full-wave rectifier. Full-wave rectifier uses the two diodes that converts the AC, two out of the AC signal into a DC signal. It uses the center-type transformer. Compared to the off-wave rectifier, full-wave rectifier gives the high efficiency output. So for this full-wave rectifier gives the output high efficiency.
So next one is about prototype. This asking from secondary C.
So in this stage, we're going to explain the prototype stage. So we're going to build a full-wave rectifier. So this is the full-wave rectifier diagram. To build the full-wave rectifier, we actually need a step-down transformer, two diode, silicon diode, then a load resistance, then filling capacitor. So first thing, what is going to happen is by giving the AC input to the transformer is reduced the voltage and become in safe level. So there are two cycles. One positive cycles, the input one end will be become positive and D1 conducts and D2 will be reverse bias and current flows in the same direction. In the negative cycle, D2 conducts and another end will become positive and D1 reverse bias current flows in the same direction. So since the current flows in the same direction, AC signal is converted to a DC signal. In this prototype, we have two operation amplifier. With this, we are working with
So the last stage is about test. I will make Darshini as one secondary.
So hello everyone, myself Darshini. So today I'm going to explain about the testing part of Precision Rectifier. So after building the circuit, testing has been the major important part. For Precision Rectifier, we are going to test DC voltage output using a multimeter. Next is simple voltage and the efficiency. The ripple factor will tells us how much AC components are still present in DC output. So if ripple factor is high, the capacitance level will be high and the op-amp conditions will be low. So to rectify them, we are using an voltage regulator. Next is the applications of Precision Rectifier in industries. We will use in thermal conductance and the overload of the circuits. Majorly, we will use Precision Rectifier. So the real life applications of Precision Rectifiers are there are many electronic gadgets which use Precision Rectifier. Some of them are TV power supply, mobile phone chargers, and LED lighting system, etc. Hence it is concluded that Precision Rectifier serves as a source for all our electronic gadgets. Without this Precision Rectifier, electronic gadget does not function properly. Thank you.
Thank you all for this valuable point about precision rectifier. Thank you.